Hi, my name is Teteje Kepsi Richard and welcome to my YouTube channel. Today, our discussion on calculus of several variables will still be on vector value functions. Last, we learned about how to evaluate vector value functions at a given point. We also learn how to sketch vector value functions, and we also learn how to find vectors in the coordinate plane of the vector value function. If you have not watched that video, please check it out on YouTube. Today, before the video ends, we will learn how to find the limit of a vector value function, how to check if a vector value function is continuous at a given point. Then we'll also learn how to find the domain of a vector value function, as well as the derivative or the differentiation of a vector value function. This will be a very interesting engagement, so please be my guest. So we start things off with the limit of a vector value function. But before we do that, please, did you subscribe to my YouTube channel yet? If no, do. It is the only way you can help me grow my YouTube channel so that I can record more mathematical content for you. So, if we have a vector value function r of t is equal to a function f dependent on t in the direction of I, and a function g dependent on t in the direction of j, and a function h dependent on t in the direction of k. We are asked to find the limit of our vector value function r of t as t approaches a constant, let's say a. It will be equal to the limit of f of t in the direction of I plus f of t in the direction of j plus g of t in the direction of k as t approaches a. How do we do that? This can be expanded. Now we find the limit of each. We find the limit of the function 10 by 10. So that will be equal to the limit of f of t as t approaches a plus the limit of g of t in the direction of j as t approaches a plus the limit of h of t in the direction of k as t approaches a. Then, with function, with limit, we just substitute the value of a in the place of t. We simplify to find our limit of our vector value function. Sample questions and see how we'll deal with it. So let's look at our first example. We say if r of t, which is our vector value function, is equal to t squared I plus 3tj plus 5k, we should find the limit of r of t as t approaches 2. So how do we do that? So the limit of r of t as t approaches 2 will just be equal to the limit, this is our r of t, so the limit of t squared I plus 3tj plus 5k as t approaches 2. So what are we getting? We get the limit of t squared in the direction of I as t approaches 2 plus the limit of 3tj as t approaches 2 plus the limit of 5k as t approaches 2. So our limit of r of t as t approaches 2 will just be equal to, we substitute here, so we get 2 square I plus 3 times 2j plus, since there is no t component there, we consider that as constant. We can say the limit of our r of t as t approaches 2 will be equal to 2 squared is 4, so that will be 4i plus 3 times 2 is 6, that will be 6j, then plus our 5 in the direction of k. That becomes our limit of r of t as t approaches 2. I hope you get that. It's not anything difficult. Now we look at the second example. You can pause the video and try solving. You say we should find the limit of t squared I plus sine tj plus cos t in the direction of k as t approaches pi over 3. Remember, pi in radian, pi in degrees is just 180. So 180 divided by 3 is 60 in degrees. So we can say that the limit of t squared in the direction of I plus sin t in the direction of j plus cos t in the direction of k as t approaches pi over 3 will be equal to the limit of t squared I as t approaches pi over 3 plus the limit of sin t in the direction of j as t approaches pi over 3, then plus the limit of cos t in the direction of k as t approaches pi over 3. So what we have, we just have to choose. We have pi over 3 all square I plus sine pi over 3 j plus cos pi over 3 in the direction of k. So we can have pi square over 9, 3 square is 9, in the direction of I. Then remember I told you that pi in degrees is 180. So 180 divided by 3 is 60. Sine 60 will be root 3 over 2, then in the direction of k. Cos 60 is half, so half in the direction of k. And that becomes our limit of t squared plus sine t squared in the direction of I, plus sine t in the direction of j plus cos t in the direction of k as t approaches pi over 3 will be equal to pi square over 9 in the direction of I plus root 3 over 2 in the direction of j plus half in the direction of k. I hope you got the same answer with mine. We'll solve more example on this so that you'll be abreast with the concept. So let's look at our third example on this. They say we should evaluate the limit of t squared minus 1 all over t minus 1 in the direction of I plus 1 over t in the direction of j plus 3t in the direction of k as t approaches 1. So how do we solve that? So we can say that will be the limit of t squared minus 1 over t minus 1 in the direction of I as t approaches 1 plus 1 over t in the direction of j plus the limit of 1 over t in the direction of j as t approaches 1 plus the limit of 3t in the direction of k as t approaches 1. So remember, this is differences of two squares. So we can say this is the limit of t plus 1, t minus 1, all over t minus 1 as t approaches 1, plus the limit of 1 over t in the direction of j. Remember, there is I here, plus the limit of 3t as t approaches 1. So you can see that this will divide. What is here? You have the limit of t plus 1 as t approaches 1 in the direction of I plus the limit of 1 over t in the direction of j plus the limit of 3t k in the direction of k as t approaches 1. So now we substitute. That will be 1 plus 1 I plus 1 over 1 j plus 3 times 1 k. So 1 plus 1 is 2, so we get 2i. 1 divided by 1 is 1 times 0 will be j, so that will be j, then plus our 3k. Then we can say the limit of t squared minus 1 over t minus 1 in the direction of I plus 1 over t in the direction of j plus 3t in the direction of k is nothing but 2i plus j plus 3k. I hope you understand this very well. So our last example on limit of vector value function. Please feel free to pause the video and solve this. We say we should evaluate the limit of t cubed minus 1 over t minus 1 in the direction of I plus 4t squared in the direction of j plus 5t in the direction of k as t approaches 1. So how do we do this? So that will be equal to the limit of t cubed minus 1 over t minus 1 as t approaches 1 plus the limit of 4t squared j as t approaches 1 plus the limit of 5t k as t approaches 1. So look at this. This is cubed. So when we substitute 1 here, remember that we get 1 minus 1 and the down will be 0. And any number divided by 0 is undefined. So we can't just substitute like that. We need to use L'Hopital. So L'Hopital says that differentiate. Please check out my videos on evaluating limits using L'Hopital. So we evaluate the top different, we differentiate the top differently, differentiate the down differently, and check whether when we substitute the 1, whether it will be equal to, whether the down will be undefined. If not, then we can substitute and evaluate. So we can say that this will be the limit. When we evaluate this, when we differentiate that, we'll get 3t squared. The differential of 1 is 0 over the differential of t will be 1 as t approaches 1. Then plus this, we don't have problem with it. So we still have the limit of 4t squared in the direction of j as t approaches 1 plus the limit of 5t in the direction of k as t approaches 1. Now, remember this will be the limit of nothing but 3t squared as t approaches 1 in the direction of I plus the limit of 4t squared j as t approaches 1 plus the limit of 5t in the direction of k as t approaches 1. Now we can substitute. We get 3 times 1 squared in the direction of I plus 4 times 1 squared in the direction of j plus 5 times 1 in the direction of k. When you evaluate, 1 squared is 1 times 3 will be 3. We get 3i. 1 squared 1 times 4 will be 4, so 4j plus 5k. And this becomes the limit of our vector value function. I hope you understand this very well. The next thing we'll talk about is the continuity of a vector value function. So our next stop is the continuity of a vector value function. So please, last we learn how to evaluate vector value functions at a given point. So they say that if a vector value function r of t is equal to, let's say, f, a function of t, a function dependent on t in the direction of I, plus a function g dependent on t in the direction of j, plus a function h dependent on t in the direction of k. Then it's said to be continued at the point, say A, where A is constant. If r of A, which is evaluating the vector value function at the point A, is equal to the limit of the vector value function as t approaches A. So that's how we evaluate the point or substitute the point into our vector value function. Then if you find the limit of the vector value function as the independent variable t approaches A, and they are equal, then we say that the vector value function is continuous at that point. If they are not, then it is not. So we say, show whether or not the vector value function r of t equal to t squared I plus 3tj plus 5k is continuous at t equal to 2. So remember, this vector value function is said to be continuous if r of 2 is equal to the limit of the vector value function as t approaches 2. So remember, r of t is equal to t squared I plus 3tj plus 5k. Now r of 2 will just be equal to 2 squared I plus 3 times 2j then plus our 5k. There is no t component there. Our r of 2 is equal to 4I plus 6j plus 5k. So that's our r of 2. Now, we need to find the limit of r of t as t approaches 2. So this will just be equal to the limit of our vector value function, which is t squared I plus 3tj plus 5k as t approaches 2. Remember that is equal to the limit of t squared I as t approaches 2 plus the limit of 3tj as t approaches 2 plus the limit of 5k as 3 approaches 2. So we just substitute. We'll get 2 squared I plus 3 times 2j then plus 5k. Also, there is no t component there. So we'll get 2 squared 4i plus 6j plus 5k. Remember, when we find r of 2, we add 4i plus 6j plus 5k. And when we find the limit of r of t as t approaches 2, we got 4i plus 6j plus 5k. So we can say that our r of 2 is equal to the limit of r of t as t approaches 2, all equal to 4i plus 6j plus 5k. Therefore, our function, therefore the vector value function r of t equal to t squared I plus 3tj plus 5k is continue at t equals to 2. I hope you get that. So solve one more example on the continuity of a vector value function. So they say if r of t is equal to e exponent ti plus sine t in the direction of j plus ln t in the direction of k, we should find r of pi over 4. Then the limit of r of t as t approaches pi over 4. Then the c passing is r of t continue at t equal to pi over 4. So that's the question. We need to solve that. So remember, our r of t is equal to e exponent ti plus sine tj, then plus ln t in the direction of k. Then we can find our r of pi over 4. That will be equal to e exponent pi over 4 I plus sine pi over 4 j plus ln pi over 4 k. Remember, pi in degrees is 180 divided by 4 is 90 by 45 degrees. Sine 45 is root 2 over 2. So we can say our r of pi over 4 equal to e exponent pi over 4 in the direction of I plus sine pi over 4 root 2 over 2 in the direction of j, then plus ln pi over 4 in the direction of k. So that's the first aspect, that's the A aspect of the equation. And the B say we should evaluate the limit of r of t as t approaches pi over 4. The B aspect, you know how r of t is this. So the limit of r of t as t approaches pi over 4 will just be equal to the limit of the vector value function e exponent ti plus sine tj plus ln t in the direction of k as t approaches pi over 4. So this will just be the limit of e of ti as t approaches pi over 4 plus the limit of sine tj as t approaches pi over 4. Then plus the limit of ln t. The limit of ln t in the direction of k as t approaches pi over 4. So again we substitute. So e exponent pi over 4I plus sine pi over 4j, then plus ln pi over 4 in the direction of our k. So that will be equal to e exponent pi over 4I plus this in radian again, that will be sine 45, which is root 2 over 2 in the direction of j, then plus our ln pi over 4 in the direction of k. So you can realize that, so this is our B part of the equation, the C part. You can realize that our R of pi over 4, which is equal to e exponent pi over 4I plus root 2 over 2j plus ln pi over 4k, is equal to e exponent pi over 4I, is equal to the limit of R of t as t approaches pi over 4, which is e exponent pi over 4I plus root 2 over 2j plus ln pi over 4k. So we can say our R of pi over 4 is equal to the limit of R of t as t approaches pi over 4, all equal to e exponent pi over 4I plus root 2 over 2 in the direction of j plus ln pi over 4 in the direction of k. Hence, our R of t is continue. Is continue at t equal to pi over 4. Please, I hope you get that. You get that. This is very simple. The next thing we are going to do is to find a domain of a vector value function. So our next step is to find a domain of a vector value function. So let's say if R of t is our vector value function and it is equal to a function of f depending on t in the direction of I, and a function g depending on t in the direction of j, plus a function h depending on t in the direction of k. Then the domain of our R of t is the set of all possible values of t, except those values of t that will make any direction of the R of t undefined. So remember, when we have a denominator to be 0, a function will be undefined. When we have the square root of a number, the square root of a negative or a 0, the function will be undefined. Then, when there is a logarithmic functions, remember that when it is 0 or a negative number, that it is less or equal to 0, that function will be undefined. So you check each of the directions, I, j, and k direction of the vector value function, and see, is there any possible values of t that will make the function undefined? You check for all. Then, the domain becomes the set of all possible values of t, except those values of t that will make any of the direction undefined. Now let's take some sample question. Maybe you get a concept better. They say if R of t is equal to ln ti plus e exponent negative 3tj plus t squared k, we should find the domain of R of t. So we check it 10 by 10. So is there any value of t? This is a logarithmic function. Is there any function of values of t that will make a logarithmic function undefined? Yes, there is. And what are those values? Those values are 0 and any number less than what? 0. So we say 0 when t is equal to 0, or when t is less than 0, then the function will be undefined for the logarithmic function. Exponential function, there is no such values. Both positive, negative, and 0 will not make this function undefined. The same way applied to a function t squared, there is no value of t that will make it undefined. So except those values of t that will make them undefined is when t is less or equal to 0. Then the domain is all the set of all possible values of t except t which is less or equal to 0. So we can say that The domain is that t is such that t is a member of all real numbers except t less or equal to what? 0. Please, when t is less or equal to 0, it will not make this undefined. But as far as it makes only one direction undefined, it renders the whole vector value function as undefined. So the domain is that t is such that t is a member of all real numbers, except when t is less or equal to 0. I hope you get a concept. Now, let's look at it. It says find the domain of the vector value function r of t equal to t squared minus 1 all over t minus 1 in the direction of I plus 1 over t in the direction of j plus 3t in the direction of k. So we'll check it 10 by 10. When t is equal to 1 here, t minus 1, that will be 0. 1 minus 1, that will be 0. It will make this undefined. So when t is equal to 1, this will be undefined. The I direction will be undefined. When t is 0, the j direction will be undefined. By the k direction, there is no such value. It takes all possible values of t. Then we can say that the domain will be that the set t is such that t is a member of all real numbers except t equal to 0 and t equals to what? 1. Then this becomes a domain of our vector value function. We'll solve one more example on this so that we'll be abreast with the concept. So we'll solve our last question on the domain of vector value function. It says find the domain of the vector value function r of t equal to 6t plus 8 in the direction of I plus 4t squared plus 2t minus 3 all in the direction of j plus 5t in the direction of what? K. So remember, we said we look for all possible value of t that will make any of the direction undefined. So look at this. These are all simple functions. So there are no logarithmic functions here. There is no square root and there is no fractions. Then we can say that all the values of t, all the possible values of t will satisfy this function. That's no value of t will make this function undefined. Then we can say that the domain is that t is such that t is a member of all real numbers. I hope you get that. This is very simple. So we'll end it here today. Please check out my videos, my other videos on calculus of several variables. Until we meet again, remember to subscribe to my YouTube channel, like, comment. Your comment keeps me going. My name is Teteje Kepsi Richard.